Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ or multiple choice question in front of you. This is about a carbonate ester. Okay, so you can see the question in front of you and 4 options are provided. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And remember one statement, self-evaluation is essential for improvement, and that's why you should try. And don't worry, after some time you will get the right answer with explanation. I believe you have tried by yourself, so it's my turn to give you the explanation. As usual, I first request you to look at the molecule and reagent. Now student, from your perspective, I think molecule is little big. So I suggest you please look at the reagent first. This is chromium trioxide pyridine. So what is the name of this reagent? So this is actually Collins reagent, or you can say this reaction is actually Collins oxidation reaction. And what this reaction is, it is a selective oxidation of primary alcohol into corresponding aldehyde or secondary alcohol into corresponding ketone, and reaction stops in this up to this oxidation state. And this reaction is carried out under anhydrous condition. And second important point, that acid sensitive group like this carbonate esters remain unaffected in this condition, because this reagent is slightly basic in nature, because there is pyridine here attached to this Collins reagent. So it provides the basicity and the reaction medium, and it is mild oxidizing agent because the reaction is carried out in DCMS solvent. So it's actually mild selective reaction. And you can see the structure of this Collins reagent here. By the way, I have already discussed a dedicated lecture on this topic. Please visit for better understanding. And remember student, that this reaction is carried out in anhydrous condition. That's why the reaction stops at the aldehyde stage. Means for aldehyde to further carboxylic acid, means here this conversion, the intermediate is actually JEE-diol. And since the reaction medium is anhydrous, so JEE-diol formation is not possible. So over-oxidation cannot proceed. By the way, I have already discussed a dedicated lecture explaining the oxidation of ethanol and fate of chromium reagent during the oxidation of alcohol. So please visit these 2 videos where you have a clear idea about the mechanism and the role of oxidizing agent and what's fate properly. Now let's come back to this topic. Now how this reaction happens? Actually, this chromium 6 center, means here this chromium plus 6 oxidation center is responsible for oxidizing this alcohol selectively to the aldehyde. And this is actually a simplified mechanism where I just omitted or neglected the role of this ligand. So you can see this alcohol first coordinated to the chromium center and produces this chromium ester. Later on, this proton could be abstracted by the oxygen of chromium, and ultimately it can produce the final aldehyde product. So if you want to know little details, you can see the original reaction mechanism with ligand. You can see this is the alcohol, this is the chromium, means this reagent attached with ligand, and the same process it produces the final product. So what is the answer of today's discussion? Answer is these alcohol will only be oxidized, nothing else. Where it's shown in option C, you can see this thing. Okay, and if you look at option D, over oxidation happens, so not possible. Now if this reagent is provided in your exam less than 30 seconds, how can you solve? First of all, you need to have a clear idea about this reagent. In case of chromium trioxide pyridine, you need to have a clear idea that how this reaction happens. For that purpose, you need to know the reagents. And here first this primary alcohol is oxidized into carbonyl, and over oxidation is not happened in this reagent. So this option D gone, and this is selective oxidant for alcohol to aldehyde. So other oxidation like epoxide formation not possible, and this is actually this ester hydrolysis. This is a carbonate ester, it's ester hydrolysis. This reagent is slightly basic in nature. How can it hydrolyze this carbonate ester? Because acid labile groups are protected, remains unaffected. So this is also not possible. So option C is the right answer based on this logic. So in conclusion, what you have learned today, that Collins reagent is actually mild, effective and selective reagent for alcohol oxidation to corresponding carbonyl derivative. For primary alcohol, it's aldehyde, secondary alcohol, it's ketone. The anhydrous condition or lack of water result in oxidation to be ended up at the carbonyl stage. and lack of water doesn't allow the JEM diol formation. Consequently, over oxidation means carboxylic acid formation cannot happen. And here, since the reaction medium is mildly alkaline, the acid sensitive groups remain unaffected. And chromium 6 center is actually a hard Lewis acid. So alcohol oxygen is hard Lewis base, so it coordinates preferentially compared to alkene. So that's why selective oxidation happens in the alcohol center, where this alcohol and alkyl both are present. Okay, so this is the end of the discussion. I believe this video will be useful. If it is, please help this channel to grow. If you consider this channel's contents are worthy, and if possible, please visit my another channel. So